Hello, my name is Technical.Mulberry, and I will be explaining today how a guitar makes sound. On a standard 6-string acoustic guitar with 21 frets, you can create 126 different noises. However, that only counts for each individual string on each individual fret. Guitars are capable of making thousands, even millions of different noises, sounds, and when you consider the different combinations and chords you can play, you can create music. Not many people understand the extent of the math and science that goes into creating a guitar. People hear music and most likely guitars every single day. However, they only hear the music and they may not necessarily understand all the science and everything else that goes into it. I've been playing a guitar since I was 10 years old. Not only have I been playing a guitar since I was 10, but my father started playing a long time before me, and I grew up listening to him play. This personal experience led me to do further research to fully understand the instrument I love and have been playing for over a decade. Because this is a simply complex instrument, today I will be breaking it down and explaining the two most critical parts for this instrument, for an acoustic guitar to make sound. First, I will explain the importance and math behind the construction of a guitar. Then, I will explain the science behind the strings and air and the construction combined that create sound. To begin, gaining an understanding of the mathematical construction of an acoustic guitar is important. First, to learn how a guitar can make sound, it is important to understand the math behind the construction. According to the research paper, Vibration Analysis in the Design and Construction of an Acoustic Guitar, there are 22 different math equations that go into the analysis and construction of a guitar. This research paper by Gorostietta, Hurtado et al. Explains how vibrations react with the soundboard, which is the face of the body of the guitar. The equations in Gorostietta, Hurtado et al.'s research paper account for the different movements of vibrations through the soundboard, density of the wood, dissipation loss, which is very important to the perception of sound, because a higher dissipation loss means that the sound fades away quicker. According to Gorostietta, Hurtado et al., the analysis of the wood used to create an acoustic guitar is also extremely important. Gorostietta, Hurtado et al. Explains that the wood is highly variable material and it can change with age, humidity, temperature, and many other things. Because wood is highly variable, other properties in the wood can change, like the stiffness, for example, according to Gorostietta, Hurtado et al. Also, Gorostietta, Hurtado et al. Explains that when these changes occur in the wood, the sound the guitar creates can also change because the vibrations react differently to the changes in variables in the wood. Now that we have an understanding of the importance of the math that goes into the construction of an acoustic guitar, so it will have a good sound quality, I will explain the science behind it. Now I will explain how the strings of an acoustic guitar combine with air and the construction of the body to create sound. In order for humans to hear something, there has to be some kind of disturbance in air, such as a compression. This compression will cause some airflow until it compresses the next layer, and so on until it creates a sound wave. This is according to the University of New South Wales. This sound wave travels to your eardrum and creates a tiny vibration in your eardrum, which creates the sound you hear. This is also according to an article from the University of New South Wales. The strings on a guitar are what creates the sound wave that travels to our ears. The mass, frequency, length, and mode of vibration are all contributing factors to the pitch of the sound we hear, and this is according to the University of New South Wales. For example, a string with a greater mass has a lower pitch, also according to the University of New South Wales. Another great example is when you change the length of the string by pressing it against the neck of the guitar and shortening the string, and it results in a higher pitch. This is also according to the University of New South Wales. The University of New South Wales also states that although it may seem like, or also points out that although it may seem like the string is what's creating the noise, it's not the case. The string itself slowly vibrates. This vibration travels to the bridge and into the body of the guitar, and it's in the body of the guitar where the air begins to compress because of the vibrations. And when that air is compressed, it begins to push out the sound hole of the guitar and creates the sound. And this is according to the University of New South Wales. The science behind the strings, air, and body of the guitar is what you hear when you turn on the radio. I have now explained the two critical components that allow a guitar to make sound and music. First, I explained how important math is to the construction of an acoustic guitar. Then I explained the science behind the strings and air combining with the construction of the body to create sound. Now that we understand a little more the math and science that goes into the creation of a guitar, which is such a simply complex instrument because of all of this, we can start to understand how one instrument can create millions of different sounds.